today's problem is count the number of fair pairs. First, let's go through the statement. We have been given a zero indexed array nums of size n and two integers lower and upper, and we need to return a number of fair pairs. Right? Let's get to the definition. What is fair pairs? A fair a pair of indexes is fair if the values at that index, the sum of values at that index is in the range of the given two integers, which is lower and upper. Right, so let's check with this example one. In this case, we have been given nums as 0 1 7 4 4 5, and lower is 3 and upper is 6. So let's find one pair here manually, right? So the lower the sum of the values at some index should be greater than 3 and greater than equal to 3 and should be less than or equal to 6. So if we see that this 0 and this 4, right, the sum of them it's 4, and so that it is in the range of these lower and upper. Similarly, for this 0 and this again 4, it is in the range. This 0 and this 5 is again in the range. So these are the three pairs, and this 1 and 4 is in the range, 1 and 4 is in the range, and 1 and 5 is in the range of the lower. So there are a total of 6 pairs in this question. Right. Okay, now let's get to the intuition. How should we solve this problem, right? So we know, right, nums I, we have one moving index which is I and one moving index which is j. So one possible solution is basically we iterate over the array of the nums, right, and again we run another loop inside the that loop for the nums j, and we will basically check if the nums of I and nums of j are equal or not, and one edge case would be that they should not be equal, so we will make that, right? But yeah, so in that case the complexity that we will be dealing with would be like we will be iterating over I for the 0 to n and j for the 0 to n, then the complexity would become O of n square, which these constraint won't handle because n square will be 10 to the power 10 and it won't run basically in the given time, right? So another approach that we can think of is we need to get pairs which has sum in the lower and upper range. So if I sort this nums array and I go and find the lowest, I go and find I will iterate on the all of the array, and from that array I will find basically what is the minimum sum I can make, at which index I can make, and what is the maximum sum I can make, at which index I can make, such that the sum is in the range of this lower and upper, right? And if I can find these two indexes, I know that all the indexes, all the values in that range would basically satisfy this condition, because the upper is satisfying the condition, lower is satisfying the condition, then the values in the range would be satisfying the conditions. So right, so we will be iterating on this array which is O of n, and for finding the upper and lower sums we will be doing binary search, which would be O of n log n. So the total overall complexity would be O of n log n, right? It's just simple. We will sort the nums array, we will iterate over each index, and from that particular index we will say that this particular value is nums I. We will be finding the nums j such that the j nums I plus that index is like basically lower, the sum of the values is like equal to greater than equal to that, and that would be our left index, and we will finding another index which would be right at the higher side, such that this nums I and nums j it should be less than or equal to upper, and all the pairs would be in the range of j minus like upper index minus the lower index, that we will have plus 1, right? Okay, so let's go through it. What we'll do, we'll simply sort the array, right? We will having an answer for all the I. We will be iterating the array. Let's have int n is nums I, and we are saying that my nums I is basically this, right? We have the nums I. Now we will find nums j such that the sum nums I plus nums j is barely greater than lower for lowest j possible, and post that we will be finding the nums j such that nums I is basically barely smaller than or equal to the upper for highest j possible, right? So in this case, let's say left, we will say that this is the left index that we will be finding, and this would be the right index that we will be finding, and we have the answer as right minus left plus 1, right? It might be possible that we won't find anything, so if left equal to minus 1 or right equal to minus 1, we will simply continue, right? And simply we will return the answer here. Now we just need to find the logic for these values, right? Okay, so I will be, so the possible index that we will be starting, as it is an ordered pair, we will be starting from the I plus 1, and the ending can be anything till the n minus 1, right? And we will be running a binary search here, and we will saying that this is my mid, right, which is s plus c by 2. Now this mid, if we will say if my nums I plus this mid, right, if it is like it satisfies our condition, so we will try to find the, we will go toward the lower m basically, right? So what we'll do, will basically take the left side of the uh, range, and we will say this is one of our answer that we had. Else if it does not satisfy the condition, that means my nums m, the value at the nums m is much higher. Okay, so the values at the nums m is very low, right? It is very low, yes, we will sing, because that is why the value of it does not make it greater than the lower. So what we'll do, we will try to increase the value, as it is the sorted value, so the larger values will be at the right side, so we will be choosing the right side of the value, and in this case, as it does not satisfy the condition, we won't be doing the left equal to m or something like that, yeah, right? So this should basically give us the value. If and the anything does not satisfy the condition, my answer would, left would be minus 1, so this would be condition error. Now we need to find the highest j possible such that this condition satisfies. So what we will do, we will simply do this again. We will again do this. I will just copy paste it here, and the condition would be like this at this point, and in this case, right, so we want to find the highest m. If this condition satisfies, I will simply say my right is m, but we want to find much more higher than the value, right? So what I'll do, I will choose the right part, which would be s equal to m plus 1, and in this case this I will be choosing if it does not satisfy the condition. That means my value at nums m is very high, So I need to choose a lower value if does not this transition. In that case my nums m is very high, so I need to check on the left part of the ranges, right? So this should basically give us some range, right? And this, if we won't find any index, this would be there, and we would be returning this value, right? So I believe let's change it to long as we are summing it to long should anyways work. Okay, wow. Right, so this condition is working. Let us submit the problem. Okay, so yeah, so yeah, that works. Now let's analyze it if you guys want to. So that basically gives us of n log n, and the memory that we are using is of 1 space complexity.